Hello, welcome back to our CSCI 310, our cybersecurity. And for today's will be the last lecture. So we'll cover the last part related to our the network security. Okay. So just slightly recap before when we talk about the network, including the SDN security. So we talk about the software defined network. Okay, so like including also before we talk about others, like including like some false negative, like false positive, like giving different type of result. And then also we have the some different technology applied for identification, okay, for the behavior. So this like we're going to apply. Of course, like nowadays we will we're talking how can we use the AI machine learning to help us. Okay, so to detect the behavior, of course, like by those attack. Okay, and when we move on to our the last part, we will talk about the zero trust architecture. So actually, we will discuss about this topic, like this idea, like recommend what's a zero trust. So when we move on, okay, so we will ask a question. Okay, so why we need to have a zero trust conversation? So what do we mean that when we say zero trust? That means like we never trust each other, right? So for the access control, we can think about, okay, we may try to keep the access like away from the attacker because we are never try um we never try to like trust like any other access, okay? Or in the IT security wise because it's really complex. So with so many devices, user and connections, and based on the previous topic we cover, okay, so they have lots of like attack surface. Okay, for the attacker, they may be looking for like some like configuration settings, like pretending man in the middle. So they have so many ways. Okay, so it's really complex and really hard. And then next is like what's the trust network? Okay, so when we learn different type of encryption apply it, so can we still able to trust those the network? Okay, so even we apply different type of security strategy. Okay, so because when they try to initialize attacks, so they always like it's network based. Okay, so let's say so they seemingly like just a simple and economical. So like this, then we also accept some low securities like within the network. So when we learn about the management, okay, so sometimes like we will focus on more like for the backup recovery instead of prevention, okay, and the reason why of course like cost, okay, resources limitation, all this, okay, we have to consider. So that's why there's still low security, okay, within the network. And then when we move on, because like there's lots of access, like increasing like lift the network. So when like the BYOD or we were work from home, so it's like okay, so or like the mobile devices access right now. So all these like in the environment when you bring your own device like today, so we have no way to um detect or like sometimes like okay most of probably we are not scanning or like make sure like what kind of application or like maybe your your thumb drive, your USB or other devices. Okay, so if you bring this device and then use connect to the network, then it's really um dangerous, right? Also why now the attacker they also try to shift to the like we call it identity attack. If you remember, like we try to do the phishing. So if you pay attention to lots of different type like message, your maybe the email, okay, so they will like give you some like emergency alert or like some certain attraction like, to you, like say when you click on it, okay. So they do lots of different type of phishing. Also, they try to do the credentials of thing. Okay, so they will ask you pretending okay from some like even they will make a really similar that looks exactly the same like original website. So they ask you okay, you may try to input some information, person information, and sometimes they will just like forward to the original one. Okay, so they will let you to pass the verification so they can obtain your credentials. So all this like really come away, and also the security teams they often like overwhelming. So it's really um like hard to them like to like make sure 24 hours and protect. Okay, that's all system. So we know all the backgrounds right here. And then when we try to look at this, like called the zero trust like idea has been evolving like from actually pretty for a while. So really start from really long time ago, like kind of between like 2004. Okay, start to like we call like formally establish it, and then including the network access control architecture. So we keep going, and then later we have the zero trust. These like terms are introduced in 2010, and then come like beyond this. Okay, so start to publish even Microsoft. Okay, so keep going nowadays like ongoing. So basically sometimes we call the passwordless initiative. Okay, all this, and then we try to introduce more like zero trust in this. Okay, so we start to talk about these topics. Okay, so mainly maybe we have a slow mainstream adoption, go like both a network identity model, because we have the for the network model we kind of like really expensive and challenge to imply it. So and then for identity, we think about something like we have the natural like resistance to big change is really hard. So when we need to apply for security, but normally you see when we have a huge change, of course, like really have a crisis comes out, okay, or some really cyber security attack, okay, cause like really financial issue like globally, like widely spread, then we will willing to work at it. So that's we need to know. And so far for the next zero trust, this here's the architecture, so including, so firstly we can see the main frame right here. So we have the zero trust architecture. So the core component, we have the policy engine, and then we have come with the administrator, like the engine, and then the administrator help us to maintain the policy. And then it would like interact and then communicate with like right here we have the policy enforcement point. Okay, so the PEP, okay, right here. And also for the enforcement point, so it allows them like enterprise resources to access to it, or the user device to access it. Okay, so right here the K commit. So this will belongs to the data part. Okay, and when we go back to the control, so like we have the policy engine, and then the administrator like manage all these things. And then we do have some supporting components that involve. Of course, we have the data access policy, or like the public key infrastructure, if you remember the PKI, okay. And then also we have the identity management, so we know like which device who is logged in, so who, okay. Also we have the security information and event management system. Okay, so and then inside we also have the continuous diagnosis and mitigation, the CDM system, and also we have like the industrial like companies, or like the threat intelligence, also all the activity logs. So they're working together to form the high level architecture like this is the zero trust. Okay, and when it goes down, so for the zero trust like principle, we just like try to like step one, we try to verify the accessibility. So okay, right. Okay, so we always like authenticate and authorize. So based on all available data point. Okay, so including some like user identity. Okay, based on like identity, just like the devices. Okay, some like or when you log in, so will be the RMS or anything your key, and then also the location. Okay, so also check the device health like this, and then also the data classification and the anomalies. So all this, so we will just like verify explicitly. Okay, so all this will be checked. And then second step, we always like emphasize called the least privilege. Okay, no matter like when we start trace back to what we covered before about the left out permission on this. So we always emphasize to minimize the user access. So we can just with the call it just in time or just enough access. So JIT, so all these are, so like giving some times, or like just enough access as a loss of privilege permission to access it. Also, we have some like risk based adaptive policy too. Okay, and also the data protection. So try to protect the data and productivity. So it's like this. And then we also have assumes that print. Okay, so this one try to minimize. Okay, and scope. Okay, for the bridges damage, if you know, we have lots of cases like happening in before in the history, like you should know. So there are lots of damage. So we try to prevent those like um latent movement. So by those like segmenting access through the network, okay. And then the user device or some like applications awareness, like we try to draw attention more. Okay. So and then we try to verify all the sessions, and then they are really encrypted like this, like um end to end. Okay. And they try to use the analytics to get the visibility and the drive data first, like detection. So like this. Okay. So here will be the mainly principles we are using for the zero trust, and based on this. Okay. And just like bear in mind, because like they are important principle, so we are applying. Okay, so just remember. And then for the access strategy, okay, like after we have those principle, then we move on to the access control strategy. So always I say, remember, never trust and always verify. So it's the really key idea, and then the action we're going to do. So we never trust any devices, and then we always like verify it. Okay, so for the signal, so it's just the address they make and inform decision. Okay, so we will try to like for the device, right? We checking for the device risk. Okay, we try to manage the device and then detect the threats or anything more. And then for the user, so maybe we apply the multi-factor authentication or some behavior analytics. Okay, right here. And if you remember, like we talked about like detecting a behavior, the SDN or this way, and then after we move on, then we can look at decision like based on the policy. Okay, so we can apply to the some like inbound request, and also we can we evaluate during the session all this. Okay, so all this we can like based on the decision. So maybe they can grant the like full access, or maybe they can have some limited or like not allowed access. Okay, like this, so they will be blocked. Okay, so the next part they'll move on to enforcement. So they will have the policy across like resources, all this. So is they in the modern applications, if you know the SaaS, okay, or the legacy application, all this we're going to um apply the enforcement. So using the zero trust. Okay, so this one is the overall like access control strategy, like will be the flow it looks like. And for the zero trust, like they have the access control. Okay, so right here, um, if we look at the network side, because like, if you remember, we talk about the network and identity, right? So when we for the control plane, so we try to apply the zero trust policy to the network connections, and for the identity, then we will apply to the access request. Okay, so here's the differences there for the network side and then the identity. Okay, so in the industry we're looking for is the more like for the security vendor, and then for the identity will be like they have the identity vendors right here. So in overall, we try to focus the network side, we try to focus the micro segmentation. So it's mainly focused like how can we enhance the existing like, network parameters like by shrinking the trusted network. So to each server or IP address. So here's the idea. But compared to the identity, so it's the dual. Okay, so it's dual perimeter. So we try to add the identity and perimeter where it's like it's inside. Okay, so it will define the by the some like authentication or authorization like this. Okay, so it's like doing together. And mainly like if we look at the network side, so how could apply so it limit to the network so it can like control by the customer, but they doesn't really protect the model access or passive access. Okay, so the micro segmentation approach they are very like by the vendor. Okay, like this. But for identity side, we try to apply to all assets. Okay, so natively protect the modern cloud access right here. And also we can put some like legacy internet access. Okay. flow the policy. So like this, okay. And what's the main difference and the differences like between them? So mainly you can see the scope of access, like where the zero trust like there is always they try to enforce, and then the threat intelligence like right here. So they have the signal integration. So if you remember the signal is one part of it, and then they try to integrate with the behavior, and then they take right here for the with signal, and also use the ML okay right here to across the large data set decision, so we can apply it. And this is what the Microsoft also focus on this part, okay, too. Okay. And then also they have some share some common components together, so they will try to evaluate some lecture signal for the device or the identity. Okay. So just like per application policy. So all this. And this like they work together. And then next one, maybe if you're interested, you can feel free to like read more details about the zero trust. Okay, and this like model giving from the next. Okay, so if you're interested, you can look at it. And just like going for the moving like the final fork. So just like right here, like this comment. So when they try to like implement zero trust because they are not trust each other's. So I don't really just like yeah, okay, I don't really trust who you are, just like give me some like I can verify, okay, it's a step. So okay, so just tell me, so I like in the network layer or identity, so I will try to make sure like who you are. Okay. And when we apply, like there's some example related to the router and switch security. So it's like we just like go for more some like hardware. Okay, so it will be the last one we're going to cover. So for the hub will be the level one device. So it mainly just like replicates the package to all parts. Okay, so there's no logic involved. Okay, really simple and sophisticated. Okay, so it doesn't need some like segment network. And also there's some problem like actually for the hub. Okay, so one is the broadcast system, if you know because it's a level one, and then it just like broadcast sending all the package to all connected up ports, right? So we maybe have an issue like because you try to send to all them like broadcast storm and then package collection. Okay, because like if you have two devices sending simultaneously, and so when you send a signal because they level one or like physically you sending data, so maybe if you bit by bit, so they may do have a collection like at the same time. Also they have the network and snooping. So why here also maybe happen. So it's really hard to find it. So especially to the hub. So most of the time we will switch to the like using the switch right now. Okay. If you later you see the router, then you or like you will that's what we're using right now. And then for switch is the layer two device. So it mainly for the traffic like based on MAC address. And if we are translate learning, like maybe later like digital and access or like with the digital for instance like this like topic, then you maybe for like learn about the ARP, okay, and then you have more idea like how they can transfer like forward from the network based on the address, okay, and they will create the and store the MAC address table, so they will save it this switch. So it's like physically it's really similar to hub, but like it's functionally like smarter than hub. So you can have multiple ports and then given higher throughput, and we can try to avoid the packet collision. So this is like the purpose of switch. Okay, and when we move on, and then router will be the layer three device. Okay, so it will try to routing. So you say router, so it try to route all the traffic between different network. So all these like routing through the network, it can have different network types. So we can like have the LAN, okay, WAN, okay, and then for the physical connection for this, like we have the copper, like optical fiber or wirelessly, okay, everywhere. So all these like traffic, so they will direct or like forwarding like based on the IP address. So this one will be the layer three, okay. And if you look at the households router, you say okay. If you look at the router, actually for function, actually it combined. So including the routers. Okay, even though because a router actually is a combined switch and router. Okay, two of them together. So if you pay attention, okay, so if you look at the back of the real router, so they have some switch. They when you connect the physical Ethernet cable, okay, and also when you log into your router, then see that you can set up all this like of course there's some forwarding cables and configuration. All this will be handled by the router. So inbound, outbound. So this one will be the hardware. And how about, let's say, because we talk about layer three, right? So it's the router. Then how about can we upgrade the switch to layer three? So this one we just like working the router and switch together. So this way I say, so they will be like making as one box. So they can switch. So they can happen say at the layer two, but for routering and the router it will happen on the layer three like this. So it just like combines the one box. So that's why it is an idea. Like will be the example. But of course, like for enterprise level, okay, it will be more powerful, okay, more port. But if you look at your like the home router, okay, only maybe for switch port like this. Okay, so for the functionality and then the person will be the processing power will be lower than the enterprise level. Okay. Then we have one is like called the access control list. Okay, ACLS. Okay, so this one is like when we handle configuration is the rules. So we can like allow or deny traffic. So we can set the NAT, the QoS or IDS, IPS, all this. So it can define what's the incoming or outgoing port. Okay, so we can set the inbound rules and policy, all this. So we can evaluate all these like criteria. So maybe the source IP we can define. Okay, and then what's the destination IP? What's the TCP port, UDP port? Okay, ICMP, all this. Okay, so we can evaluate all these criteria. So maybe like for if you don't want to let any like income package go into a certain destination or the server, then you can like just like drop all this like package, or like if you rejecting, or we call that like blacklist whitelist data. So we can limit the source IP like access to it. So all this like or like using which port to access. So this is the access control list for us to check. So right here, when we configure it, okay, so you will see we have the router right here, okay, 192.196.1, and also we have the maybe the switch, okay, so all these switch connect together, and then they as I all connected maybe some devices, they will obtain the IP address, okay, and then this one is the outer like network. Okay, so you can distinguish by the IP address, but sometimes they through the subnet mask. But right here you just assuming okay, right here is another network, and then they have other switch like this. They have different IP address. Okay, and we're moving like how can we provide some like anti-spoofing techniques? Okay, so like we just like spoofing because we try to use the host address, right? And sometimes we try to pretend using ARP, so another way. But for the anti-spoofing is try to like prevent many type of attacks. So especially the man in the middle, like DDoS. Okay, because like as a man in the middle, we know just like pretending like because like when you're thinking, you are talking, let's say if you're the analog, like okay, it's a computer, you want to communicate to the router, okay. But if you they try to do the spoofing, and then also they focus their like, API, the MAC address, okay, to them. So you're thinking you're talking to a router, but actually you were talking to the attackers, okay. And then the router thinking send a package to the client, but actually they're sending to the attacker. So you're just like before the user maybe they have no idea. Okay, actually they sending all the package through the man in the middle. So here's the idea. So they try to detect maybe do they have a duplicated MAC address or IP address, so it can prevent it, and also try to filtering some doing is the reserved IP address. So those that have an address, they shouldn't be routed to or like from the internet. So they try to do it. Also, they can like revise the some like path forward the RPF, so it can like respond to some like inbound package. So they will should like return follow the same path. Okay, so if they are not, then they can drop the package. So if they are not returning follow the same path, then they will know, okay, maybe they go through some main middle and then the route, so they're not safe enough. Okay, so they will drop it. So here's the idea. And for the switch, where we talk about switch, then how can we enhance the security for the port? So always the protection is use the perimeter. Okay, so maybe once inside the network, so they would stay largely wide open. Okay, and also they may be the easy to get on the network, because like maybe the lobby, conference room, like this, like public meeting space, any space they can access it. And then they try to protect or limit those that connection route. Okay, so they maybe disable some like network port. So if they're not using, or the disable some like network, so just like a jobs like they're not in use like this, then we can monitor the wireless range. So try to like use the minimum powers if they're necessary. So will be like this. And then we will move on and like keep going is the network access control. Okay, so we have these, and then for the network access control, so we have the IEEE standard, so it's the 802.1x. So this is the port-based network access control. So user, so they must authenticate to get on the network. Okay, so they can use the called the EAP or Windows. Okay, so this is EAP is the called extendable authentication protocol, or the Windows. So it's the remote authentication die in user service. So either using EAP or the Windows like together. So to giving the gain the network access control. So they will also disable some network port not use. Okay, so there will be actually those physical port. Also, they will check the duplicate MAC address. So that's how they can stop the spoofing to, if you know, and also the man in the middle attack. And also we can try to like doing some loop prevention. So when we connect to switch to each other, right? So maybe they'll each day sending broadcast traffic back and forward. So keep saying, okay, this access and this like no passing. And because for layer two, they have no like containment mechanism. Okay, for those like hopes. So if you remember the air hopes, I don't get that. So it's so easy to bring down a network, because like you never check like how many times they're broadcasting. So pretty easy. So to resolve it, just like unplug the loop. Okay, and but it's really hard to spot it. So like this, then we can use the spanning tree protocol. So so this one is the IEEE standard. So it's 802.1d. Okay, so it can prevent the loop in the switch network, and also mainly in the like home network equipment. Also, they have the STP. So spanning tree protocol, if you have a slightly advanced home router, then you can log in into platform UAC is the STP setting. You can allow it. Okay. And right here, like spanning tree, so we showing in the graph, we have multiple switch right here. They all exist, right? So from A, D, G right here. And when they try to send it, because the loop is that they let's say I have they keep broadcasting and sending the package, like even try not to confuse, because for you say the hub and then switch, like for the hub always they broadcasting, but sometimes for the ARP we need to like let's say um I have a computer A want to talk to computer C, and then I don't know, I only know the IP address, but I don't know the MAC address. Then I doing the broadcast, okay, and sending to all connected devices. And then if computer C, okay, I'm the IP address that only this one have, and I know the MAC address, so it will like return back, okay, to the computer A. So this way it will occur the broadcasting too, okay. Okay, so this way is sometimes it do like even though they are switched, they still will happen like this like broadcasting. So all of them they keep like broadcasting, and then no time to live, and then lots of loops, like it causes the will it takes occupy the bandwidth. Okay, so it makes the unstable network. So it's easy, we call the flood and then crash. Okay, like this will really happen like that. Then when we apply the spanning tree, so we try to like seek out some other switch like the downstream or like the current hopes like this, and also to that switch, so the ports can be disabled, so there are no loops that exist. Is the idea. So right here example just like giving you, okay, if there's some ports there codes like here, so maybe A can go to G, G, T, like Q. Okay, so when they code the whole here, and actually D can communicate. So and then Q go to X like this. Okay, so it's like telling you. So if the link goes down, so the STP can be activate and disable port, so they can like serve to the unique interpreted and interpreted like this. So and that's like the STP can do. So they can just like reactivate again. And we talk about like the one because like for broadcast state, so that means that we call the flood guards. Okay, so it's using, so it can limit the MAC address on an interface and only allow some specific like MAC address to access. And also we can switch the amount just the number of unit MAC address too, so we can maintain the MAC address list. And then we have the like port security active like activity, the after the MAC address limit is the reaches. So once the MAC address limit reaches, then we can activate it. Okay, so activate it, so we can just log it down. So we actually disable those like physical ports, so they will going to disconnect it. So here's the idea, and here's just give you some like more examples related to the firewall rules and policy. um and that's it. And so far, just like you don't have a quiz, but for the when we move on, I keep going. We have some like network security device, and then what's the time synchronization. The first part is they synchronize the time is important because we talk about we keep all those different type of log files, authentication, information outage, information. All this say we need to have an accurate time. So even no matter the router, firewall, server, workstation, some network applications, they so they have to make sure like all the devices make sure they are synchronized. Okay, we have the NTP, the network time protocols, they automatically update. So if you look at your device computer, okay, so you sometimes automatically enable the NTP. So it can like using an NTP server, so you can see that the pool dot ntp.org or the time missed gov. So they are all different server. So you can use the different type of server. So they are like open to public. So you can use it to synchronize. Okay, like this, and you can look and search it online. So there's so many server you can use. If you're using some maybe small device like ARM device, they require you to configure by yourself. Then you can also connect the to the NTP server by yourself too. So here's some example list like you can use, and you just need to search it, and you give your name, IP address, and there's some location. So you feel free to use all this. Sometimes the NTP server also provided by some school, okay, some university. So you can use that to synchronize your time. And so we get, if you remember, we talk about the SSL certificate, all this. So try to like the modern browser, they already contain list of just like the certificate of the writer. So okay, so like this, and so even the when nowadays some mobile phones would do the same. Okay, so you will right now maybe you see maybe like browser different like let's say Chrome. So they are not just the site unless they the CA already signed the encryption certificate. Okay. And also they will perform some check the like check the DNS record, mail address, or the space ID. So if you remember, we talked about the certificate, they have different type like the domain. Okay, or even in the enterprise level. Okay, so all this, and the browser will check those like certificate. If they are trusted sign CA, then they will certificate is trustable. If no, then they will toast like this. And each like the CA business, they are built on being the trustworthy. Okay, so if they lost their like trustworthy, they maybe just like go out. So they're not working for this one. And they do have some example of this that did you notice over here being hacked, they're not trust anymore. So um if you know like we have the self sign, okay, or something like if we use the let's encrypt because there's a domain base, then maybe sometimes like the browser still saying okay you are not really secure. So here's the reason. um we have the SSL accelerators. So this one can help stay for the encryption. Okay, so for the SSL, so it's the computational like intense. So for the large scale web host, then maybe that's a bottleneck to serve the more user. So what's the solution given? So we try to offload the process like to other hardware. Slightly different, but the process they focus on the device. It's just like way cheaper. So it's like cheaper to add multiple SSL accelerator then just like add more high availability to the web server. So here's the idea. So we add using the accelerator. So you can put it like right here. So let's say if lots of user and then they want to use the SSL, so we can like normally through the gateway or like we have router, so we try to go to connect to the brand, right? So we can for SSL accelerator, we can like can have us so it can involve right here. So you say okay, so you want to use the SSL and then the router we say so we'll use it, but it's too busy. Okay, so maybe talk to the SSL accelerator, so we communicate to SSL accelerator. So it can return, okay, so it giving will return the SSL certificate back. Okay. And once the user like receive it, so it can use it to like encrypt it using the key. Okay, so it can request it and it will go back to the gateway router. Okay, so with this way, so the web server can talk to it right now. So this is like how the SSL can help and it can return back as a scale web page as a request. So instead of like just like do this, the SSL accelerator can help to do that. And then we have the SSL like decryptors. So this one, so when the SSL encrypts like the traffic, but nobody can intercept it, right? So how can you protect your network from the data loss if you can see the web traffic? So we can use the SSL decryptor. So once the SSL is secure, how can I just like we believe a good man in the middle. So sometimes we call a man in the middle, but actually in this like architecture itself, okay, so we do have to like, try to implement the call a good man in the middle. So when the user try to this time we add in the decryptors, right? So we say, okay, they want to get the SSL certificate. So through this one, have SSL proxy or we call the decryptor, go to the firewall, internet, and website, right? So I say, and then when the user also say, and then the SSL decryptor, we say, okay, we look at it and then try to get it from the user. And then you will think about, okay, so if it requires the SSL certificate, so the decryptor want to get it. Okay, so it just like go to SSL and then return the certificate, going back, and then once the SSL decryptor receive it, okay, see, okay, and then once it receive it, then you will say, okay, so here's the certificate returned back, and then you will go back to the user. So here's the idea. Then you can use to encrypt the web page. So we let you see and then just say no. Okay. And then when you look at it and you just like compare and say, okay, where is the encrypted web page? So it would like to see and then you just like forward out. Okay. You send it. So and then you just like keep on forward to the website and website would return the encrypted web page like, as a request and return back. And just like keep going is the loop. So it's just like, okay, here's the encoded page as a request. This is what the SSL policy doing, the decryptor, then just return it. So right here you can see every every time that when the conversations they will pass through the SSL policy. Okay, so because when the package is unencrypted or sometimes they're filter examined or they are encrypted with other certificates or what they have a license on. So all these, so they are completely transparent to the end user, so they know. But the SSL policy will help. Okay, and then sometimes how can you tell if you're behind the SSL policy, you say? So sometimes we will check the certificate authorities of the CA. So if you are talking to like certain website, let's say they're using Amazon, but their certificate they're internally signed, then you are like behind the policy. So it's like this. So this idea right here. So we can look at this. So when we become a like trust internal network, so those like certificate we use like by this like tool for internal sign. So it's okay. And then if the certificate like used by this like tool when they signed by the CA, okay. So when we use it, also it works too. And Right here, we have also some like called the media gateway. So for the media gateway, it's the range of specialized devices. So it can help to convert or like connect different type of network. Okay, so maybe as like at the bridge between the network or different purpose like this. We have the post. Okay, so or like to the VOP, VoIP. Okay, also like streaming. Okay, stream the video control or telephone like broadband. Okay, internet like this. Of course, there's some other different type of media like can use encoding signaling format. So this like the media gateway can help. Okay, so the way you know introduce when they use it, they can be the one of the attack surface like for it. And I'm going to use like some hardware security modules like we call the HSM. So we use it. So maybe you can use the manage and securely manage and store some key. Okay. And actually in the enterprise level, there are some like called the key HSM right here. So you can use it, purchase it. So you can have called the crypto accelerator. So pretty similar to our SSL. So you can try to offload the computational overhead and then also and then they can also specialize the some like hardware provide optimize the performance. So is they maybe help the performance. Also, we can use it for large server web host environment, so server farms or this like cluster. So it can go for the redundancy because in the server outage, then we can still make sure the key they're safe. Okay, and of course, when we try to using this the HSM, so it can be also the timing target too. Usually they will have a bin like temper protection, some like harder than network interface. This they can help. And so far we quickly cover here the last part, and that's it for our cybersecurity chapters, and then we cover and as the last part. So there's like no more nap. So this will be our last lecture. Okay, and after the meeting week and then the break. Okay, so we have the final exam, and I will just like make it like available so you can do the taking the exam online. And of course, if you have some work to do, submit, or you have questions, feel free to contact me. Okay, thank you.